Good morning. Please be seated. Nothing happens in nature. Things evolve in nature. And this is also true in science. Bureaucrats talk about translational science. Well, translational science is not only going from impractical to practical and from no money to money, but it's also to understanding things, and that requires a lot of dialogue and heavy-duty work. Engineering is one discipline. Neuroscience is a completely different discipline. That is at least what we thought 20 years ago. Merging the two disciplines is, of course, very difficult, and it takes a lot of communication back and forth. It requires some personal chemistry between the players, as well as the goodwill from both parties. The first time I met Professor Ken Weiss was a long time ago, and it took about 5 minutes for us to realize that we clicked. We understand each other, at least on various goals, and this is how I think should happen even today, that we have to combine or bring together the right kind of people. The development between the first electrodes and what we will be seeing today and tomorrow, I think, is quite astonishing. I don't want to tell you about the history because this is not my job. All I'd like to say that welcome to the first ICAN meeting. It is astonishing that despite the fact that this industry has been around and active for a long time, but I think without exaggeration we can say this is the first meeting where people interested in chronic use of probes and engineers come together. We just hope very much that this will continue, and the dialogue between engineers and neuroscientists will be much stronger and more effective than it used to be in the past. My good friend and colleague, Jussi Kuhn, is responsible for all the good things that happened at this meeting, and he is going to tell you.
Things too.
I take the blame for those things, and he would like to tell you about what happens today and what happens tomorrow, and some practical aspects.
All right. Thank you, Yuri. Welcome to the first conference of Advanced Neurotechnology, and my colleagues and friends are talking about the possibility of having this meeting for over the many years. I'm really glad to have the meeting happen today. And as you can see in the agenda, we will have a keynote presentation today and tomorrow, and two today and one tomorrow. And we will have an interesting panel discussion in the afternoon. But one thing that I want to remind you is that we will take a group picture outside at the stairs, and Catherine will let you know how to arrange a pose and before lunch. So when you're coming out from this podium, we will take a picture, and we'll announce it also just before the lunch. And tomorrow we'll have a poster session, so you will not see the table outside at the lobby tomorrow morning. We'll have a little small tables, and we have an interactive discussion among the poster presentation among the participants. With that, I hope you will enjoy the meeting. And here, Dave Monson, Dean of College of Engineering, will give a welcoming remark.
Thanks, Yusik. Good morning, everyone. And if you're not from Ann Arbor, welcome to the University of Michigan's North Campus. Thank you all for being here. And a special thanks to the conference sponsors, the National Science Foundation, through its International Program for the Advancement of Neurotechnology. We welcome all of our ICAN global partner institutions, and also sponsored by Integrated Neuromorphic Electronics and Microsystems, so we thank them. The University of Michigan is honored to host your inaugural ICAN conference. Across this vast academic enterprise, we pride ourselves here at Michigan in tackling big questions and problems with the aim of using our intellectual resources for the benefit of society. Often we make great progress through collaborations among our 19 outstanding schools and colleges. Given this conference's mission to bring engineers and neuroscientists together, to review recent advancements in neurotechnology and neuroscience, to define the need for the next generation tools to move neuroscience forward, and to enhance translation of technology This particular location is perfect for this meeting. A couple of things. First, this building is just up the road from the U of M health system. Again, if you're not from Ann Arbor, if you are from Ann Arbor, you know that. The University of Michigan president, Mark Schlissel, is both an MD and a PhD. And the University of Michigan executive vice president for medical affairs and also the dean of medicine, Marshall Runge, has a background in translational consortium research programs. The U of M health system is a national leader in healthcare and biomedical innovation, and it provides a phenomenal real-world laboratory for the type of work that we're talking about today. Second, we're literally just down the street from the College of Engineering, a few steps away, and that is my home unit. The College of Engineering is active in the BRAIN initiative through technologies developed in our Lurie nanofabrication lab, including advanced microscopic neural probes to map brain functions. That work is really a long line of historic work here on this campus. At the end of last year, Yusik Yoon, who is chairing this conference or co-chairing, and Ken Wise, who will speak next, they came together with other U of M faculty and collaborators from Europe and Asia to form an interdisciplinary team to help unravel mysteries of the brain. The NSF funded a $5 million grant to support the work of experts in sensors, electronics, data analysis, and neuroscience. I see lots of students in the audience, and I imagine some of you are working on that project. Also, late last year, researchers announced that they had built and tested in mice neural probes that hold what are believed to be the smallest implantable LEDs ever made. The probes were built here at Michigan and demonstrated at NYU. Together, the College of Engineering and the University of Michigan Health System provide considerable strength. Both are ranked within the top dozen institutions in their fields. In the case of engineering, latest US News ranking was number 6. UMHS is COE's largest research partner, and the College of Engineering is the biggest UMHS research partner. At any given time, we have about $250 million of joint research underway. And since 2012, the Biomedical Engineering Department, which had been a department in the College of Engineering, since 2012, it has been a joint department with the School of Medicine. It is the only department on our campus that has 2 parent schools and colleges. That was really came about because as an outgrowth of all the joint work going on between engineering and medicine. Yusik and Ken are faculty and emeritus faculty members respectively in the EECS, Electrical Engineering and Computer Science, and Biomedical Engineering departments. Together within a university that is renowned for collaborations across a breadth of excellent academic units, medicine and engineering have built a remarkable ecosystem for conducting complex, large-scale research. Moreover, at U of M, we embrace translational research. For example, our Coulter program, which is an endowment fund for translational research and commercialization of new products to improve healthcare. And ICOR. ICOR is the NSF program to train teams to launch startup companies. University of Michigan was one of the first 3 sites in the nation for ICOR, the others being Stanford and Georgia Tech. And we have trained more startup teams than any other ICOR site in the nation. Those teams generally consisting of faculty members, researchers, and graduate students. Your presence today honors the current work in neurotechnology, but equally speaks to our commitment to partner with all of you to make an even greater difference in this realm. The opportunities for impactful collaborative breakthroughs are clearly present in the minds in this room and in all of the institutions that you represent. I hope these 2 days inspire more progress and spark even greater ideas. Please enjoy your time in Ann Arbor. I appreciate your commitment to this important work and wish you all the best for continued success. Thanks a lot.
So on one of the devices I won't show is we actually developed folding things here so you could actually fold these over flat. So you could keep it well under 1 millimeter at the surface. And anyway.